Okay, so good afternoon. So I'm here to talk to you. So it'll be a very different talk than the very interesting student talk and the other talk you heard this morning. So my day job is to work with customers and help them understand why they need to transform their network and what are the inflection points to get them to this end state. So today, the realities are such that you cannot think of IPv6 in isolation. And actually, a lot of my enterprise customers, they're more worried about taking advantage of SDN, network virtualization, than they are about taking advantage of IPv6. So, and actually, the other thing that I wanted to say, so before coming here, I did a search in Google to see who is talking about SDN and IPv6. And the most content that comes back is folks comparing how long it took for IPv6 to get where they are and how fast SDN got to where they are, right? And they're trying to make intelligent comparison as to why these two things are related and the properties of both technology. But the point of the matter is, with V6, it took us a long time, and in the meantime, other technology came around. And so it's very important for all of us to understand the landscape. So this is, that's my own company that made me put this up there. So this is forward-thinking, a forward-looking statement, so you guys can read it at your leisure. So as I said, I'll cover where we are today. So it's important. So any transformation, your as-is state is as critical as having an idea where you want to go. And then how you undertake that journey is also critical because most enterprise, their primary business is not to run a network. It is actually to deliver business ROI, right? So the pragmatic steps you're going to select are very important. Then I'll talk about the journey to software-defined, right? Software-defined is not something new. It's a concept for all of us that have been around this industry for a while understand very well, but it is a concept that we need to understand how it applies to networking and how it impacts the networking paradigm. Yes, I said up front, it is very possible that everything you can do with SDN, you can do it with another technology, right? There's nothing new. We keep reinventing ourselves here. It's about scale, it's about agility, and how fast can you impact the bottom line or the top line of a business, right? Then I'll cover a little bit of how to go about transforming IPv6 once you understood the SDN space, and then I'll try to put everything into context. So let's review today's network. So very easy. This is a visual that I am using over and over, but the main message here is that today's network are over-provisioned and underutilized. And that is a big issue because it's expensive and it's very hard to find the right size, to be able to know ahead of time what the business will need, right? The business has gotten used to server virtualization. They understand the ability to scale up and down, and they don't understand why the same thing cannot be achieved with networking, right? So this cost, right now, when I talk to network folks, they are a pain to the business. They're not an enabler to the business. And therefore, they always are an afterthought, right? Well, you know, I can spin up a VM up and down very quickly. I can't do this with my network. It's black magic. I got to go and talk to those guys, and it's very difficult to get there. So the demand of the business is very clear. That is why, by the way, you see things such as network function virtualization and SDN coming around, because it's about delivering that scalability and that agility. So what I wanted to show here on this is that let's not be uncomfortable here, right? The concept of virtualization, both on the storage side and the server side, is not new. That is why SDN software-defined networking is taking hold so quickly, because all of us understand what this means, and we are comfortable with this message. The speed to provision is something the server guys and the storage guys are used to. The network is always held back. I have to wait to deploy a new service. I have to wait. That waiting time is costing real dollar to my customers. So let's review this. So these are the megatrends. I hope there's nothing new in here, but it's all about saying you need to have a network that can deliver this converged platform. You need to have a network that is resilient, right? That is virtualized, so you can slice part of the network for specific traffic, for security reason, for regulatory requirements, for business reason, right? You want to be able to deliver this just-in-time community of interest for this day, for this minute, and then tear it down. That's the goal. That is why we are in an inflection point and why everybody is jumping on the SDN and NFV bandwagon. Not because it's the latest cool buzzword. It is because it is truly an answer to the pain points that we are dealing with. Okay, so explosion of devices, excess data, everything over IP. I mean, the speakers this morning all talk about the Internet of everything, right? It needs to be unified. It needs to be context aware. You need to have end-to-end capabilities. Of course, a lot of what I'm saying here, well, I can achieve this if IPv6 was pervasive, right? But the fact remains that it isn't, right? So we need to build this converged platform. We also need to ensure open standard-based. Why? Because the same way in the service space we went through some type of commodization of platform, sometimes of default server. I mean, with, of course, high-end servers, which they still have a space, but really the balance has shifted from proprietary OS to off-the-shelf OS with a few high-end servers. The same thing needs to occur on the networking side. So we need elasticity, and we need distributed, right? So the student speaker talked about the importance of distributed. We really need to bring the network to this level to unleash this untapped innovation that we of connected everything, right? So what I wanted to show here is that, and I tried to give you a hint, is that these are two trajectories that have occurred both on the server and the storage side. And the important aspect is, I mean, how many of you remember when servers started to when we started to introduce virtualization, everybody said, there's no way you would ever run an enterprise-grade workload on a virtualized machine. No way. And there was a lot of pushback when this came along, right? And what happened? More and more technical solutions were brought to bear, but really there was more competitors. At the beginning, there used to be only one provider. As we came along, enterprise alternatives came to bear. So I, as an enterprise user, I can now have a credible, viable virtualization solution for my servers. And if you look at the storage trajectory, it's quite similar, right? There's a little difference, right? Servers, they started out by getting big, and they were underutilized, like networks, and then we started virtualizing, and then we started having credible alternatives. The storage space, they did it a little bit different. They right away realized, oh, I need to separate my control and data plane, right? So they got that right, but they still today are kind of manual still. Part of this paradigm, abstractions of the different layers enabled the transformation. So to us, to the industry, to anyone working in this space, these are the building blocks and the explanation why SDN is taking hold so quickly. Right? So in order to transform the network, we need to make sure that the hardware can be abstracted through an abstraction layer, API, so that you can program to the data plane and you can program to the control plane. The same way this occurs on the server side, we need to do the same thing. And then once you've enabled that programmability, then you enable application to inject, to program business rules into the fabric. So again, you are able to build what you need at the time you need to build it and tear it down. And all of this can be done automatically in a programmatic manner. So for us, these are the pillars that needs to be thought of as you're looking at network transformation, right? For us, mobility is the transformation engine. The fact that all of us are mobile and it's only the beginning, that is forcing the network to transform, forcing change into the way we interact with people, apps, and data, right? As well as things, of course, because the Internet of Things for me is mobility on a steroid, right? We've done people to people. That's what mobility is. It's about accessing your data or your application. Well, things is like unstructured data. It's yet another magnitude of things that needs to interact with you. And then, of course, you need to bring in the distributed analytics to make sense of all that data. So very important, so that ties to big data. Big data and the tremendous amount of progress we've done there, the strength that we have around structured and unstructured data, right, is another key for unleashing this next steps in the evolution of technology. And then, of course, cloud really is helping with all of this. So tomorrow's network, it's all about, of course, by the way, when we say software-defined, no one should ignore the fact that hardware is going to continue to be worked on, to be innovated, right? Look at the server trajectories. We haven't stopped working on servers, right? You have low-end servers, but you still have very high-end servers which are built for purpose, right? So we see the network actually following a very similar trajectory. But the key to the software-defined world is all about APIs. It's all about programmability. It's all about having a mean to deliver this scalability. So this is my connectivity ring. So the first, foremost important aspect is open standard. Without open standard, you're not going to allow innovation to be reintroduced. Being locked in a specific architecture may be good for the vendor, but it's not good for unleashing innovation, right? The next pillar is around software-defined, and that's what we're going to be looking at. IPv6 is a pillar of that transformation because everything, people, apps, data, and thing needs to be connected. So it's clearly a mean to enable this. And then, of course, network virtualization is taking what was trapped in hardware, virtualizing it, and then composing it through service chaining throughout the network at your needs, at your disposal. So this slide is from the ONF, Open Networking Foundation, and they defined software-defined as follow. So they have 3 layers, very easy. They have infrastructure, control, and application. That's the SDN architecture. The infrastructure needs to be open standard-based so that it can be programmed as needed. You then need to separate control and data plane again. You abstract the control plane that used to be trapped in individual hardware elements, and you abstract it so that you can treat it as one. And then you expose this API to the application so that the application can program whatever flow they need, such as a specific quality of service, just as a specific security rule set for the network to act upon. I wanted on this particular slide to give you a view of what do we mean by software-defined. This is almost like software-defined 101. Notice here, again, I'm taking the ONF architecture, but I'm adding key design tenets, which would apply to software-defined data center, would apply to software-defined storage, would apply to software-defined networking. It needs to be agile, it needs to be automated, it needs to be optimized, and you need to have predictability, right? So that you can take action. If you can achieve these 4 tenets, then you've achieved a software-defined framework that will enable your business needs to be implemented throughout the fabric, throughout this converged platform. Okay? At the center of this model is application programming interface. We are really in a DevOps world where more and more you program to your needs. Having that open standard-based API is the key to unleashing software-defined architecture. So with this slide, I actually thought it would be useful to look at current network architecture, right? So today, software applications cannot tell the network, or the network is unaware of the application need. The network has to guess as to what the application really needs. And how do we do this? We do this by deploying probes throughout the network and trying to make intelligent decisions as to what could be required for the network. It obviously would be a lot easier if the application could direct the network to actually act upon their need. And then the other part, which is also very important, is that we have right now, inside each individual network element, both control and applications plane trapped together. And which means it's very hard to infuse rules over discrete control elements. Very hard to have a stable view, very hard to have a coherent view, right? Needs to stabilize. Also, what we saw is the rise of hardware appliance. Because it was very difficult to get the network to do what it needs for all types of applications, we ended up building a lot of hardware appliance, which grew the complexity of the network. I mean, Alain showed us a very interesting network this morning, right? Grew the complexity of the network and really turned around. It made it black magic, as I said, right? Remember when I said that the server guys and the storage guys really don't understand the network because the network is too complicated? That's part of the black magic. A software-defined architecture actually needs to flip the model, right? It needs to go software. Application need to be able to direct through an API the network for specific QoS setting, for specific security, needs to direct the network and say, this is what I need. Once you do this, then the network can be built to actually meet that traffic requirement. So the end user experience is actually very important. And that is going to be one of the tools that we have. What if I could program my network to say, treat this traffic that is IPv6 according to those forwarding rules, right? If I can do this, now I have an optimal way of introducing IPv6 into my fabric while also embracing SDN. And so basically what we're seeing, and whether it is SDN or NFV, we're seeing the rise of software appliances and really the hardware part of it. The hardware appliances are being less and less prevalent. The advantage of having a virtual CPE, for example, is the ability to actually program that CPE according to your business rule or introduce new functionality very easily. Always easier to deal with the software. Okay, so this one should be pretty obvious. In order to win into the next decade, especially with the rise of security concern, especially with more and more traffic being encrypted, the network is currently quite blind to the traffic. Now, of course, we are very, we are technologists. We can always build some kind of engine that tries to guess at what kind of traffic is going on, but it's a lot easier if I am told by SAP, this is what I need. Or if I'm doing a video conference, I am told by the link client or the link server, this is what I need for this particular communication, right? A lot of the folks that are doing link today, as an example, often have to trade having the right QoS setting when it is a video call versus having a secure channel, right, and having that channel encrypted because they can't do it both. Or they do it ahead of time and then they become over-provisioned to deliver that optimal experience. If my link server is able to tell the network, I am about to start a video stream, and the network is able to set up the right flow so that that traffic is handled differently, then I've changed the paradigm. And the end user experience is mind-boggling, actually. It's just very, very good. So this is, so we at HP, we've been working on SDN for a long time. We do have SDN applications, load balancing application, virtual cloud application, network optimizer, and network protectors. I strongly suggest you go to our website. You can see all that information. The thing that I wanted to zoom in here, which I thought was important as well, if you look at the consumer market, right? One of the reasons why the consumer market is thriving so much is that they deliver the concept of an app store, right? So anyone, all of us, can pull down the application we want, the functionality we want to do our daily actions, whatever they are, activities, right? If an enterprise IT has to think ahead and has to know, I need to deliver this functionality or this functionality, it really is restricting innovation for that particular enterprise. What if I was able to deliver a marketplace where I could pull down the application or the functionality I need when I need to? Again, with programmability, and this is only the beginning, with programmability, you can do all of this. You can also build enterprise version of the consumer market, because I don't want you guys to think that enterprise are going to think the same way as consumers. They don't, right? They are far more, they don't move as fast as the consumer side of the house, but still, the concepts are the same. And then I know there's a few other talks after me that are going to be covering NFV, so I just wanted to say that NFV is network function virtualization, which you have on the right-hand side. It is taking hardware, network functions which were trapped in hardware and virtualizing them. And then it's providing the ability to orchestrate these network functions to deliver a service, a new service. It is all about leveraging IT and applying this to the telco side, which if you think we have expensive hardware appliance, you haven't looked at the telco network. Their appliance is extremely expensive. So it's a cost reason, but at the same time, it's a need for innovation. It's a need to transform and to try things instead of having 2 years. You know, the innovation cycle, hardware-based innovation cycle is slow. You got to trial it. You got to think ahead of the need, right? And what we've seen on the telco side, it sometimes takes them 2 years to trial something. Well, they're taking a lot of bets. But if they can have a software solution, then they can trial it easily, retire that service if it doesn't work, and then move at the speed that we've seen Google and over-the-top providers move at. So again, this is all about leveraging what has occurred elsewhere and applying it to the network finally. So this is a slide that just says, what are the value of programming? The value is about enabling the business to finally have a say, have SAP, tell the network, this is what I need. So this is really quite transformative, and it will break the last barrier. It will enable delivery of new services. So again, it's very important that programming interface needs to be standardized. There's a lot of work occurring in the standard. So I want to pause a little bit on what I said at the beginning when I said, you know, people, when you do Google search right now, you see that the comparison between SDN and IPv6 is around the time it took them to get them here. On the software-defined side, there is a lot of work going on, a lot of activities in the standard bodies. So I would say not everything is dry yet as far as these protocols, but you don't have to go black and white, right? You can run in hybrid mode without any problem. So you don't need to boil the ocean. Choose your business need. If it is voice, do it for voice. If it is for security, do it for security. Do it to meet your need. Or if it's, we were working with a city and they wanted to do video streaming within that city. Brand new network, nothing existing yet. Use SDN in that brand new network, right? Greenfield deployment. You don't have to worry about the rest of the environment. So again, choose wisely. So let's take a peek at IPv6. I mean, because everything needs connecting, then that's the main reason why IPv6 is required. We've got to stop being restricted by IPv4. I mean, there's a lot of issues with IPv4 and the world we live in. So think of IPv6 as an enabler instead of something that you need to do because you just need more addresses. Actually, I would say that for the past 10 years, we've actually hurt ourselves by thinking this way. So combine V6 and the model that V6 brings to the network, and then introduce software-defined at the same time to leverage both sides of the world. So let's take a look. So again, remember, my work is primarily with enterprise, and what I heard this morning from Alain's great presentation is that the enterprise are really the laggards here, right? The service providers do a lot of work, the content providers are doing a lot of work, but the enterprise, remember, they are quite timid, and they are concerned about many other things. Show them the business need, and they will act upon. If there is no increase of top of line, maybe they'll go for OpEx, CapEx. That's what we see in the telco space, right, with network function virtualization. It's a cost requirement as well as an innovation requirement. But think about the enterprise. They need that business, that low-hanging fruit, that reason why they want to move. I wanted you also think about, why do I say untapped innovation? I want you to think about data and the world we lived in when we had structured data, right? Everything was, the rules of engagement, the databases, everything was predefined. Someone thought about all these rules of engagement, and we built this structured environment. And then came along mobility, came along the ability for all of us to generate petabytes of data. And that became, today, the numbers say 90% of data is unstructured, right? So we needed to cross that chasm and say, we need to deal with unstructured data. Think of the SDN transformation as going from structured to unstructured. Software-defined networking. It needs to occur, and that will unleash the next phase of innovation. So why would an enterprise need to move? Well, address depletion, fate sharing, or the side effects of carrier-grade NATs, right? Security requirements, because V6 happen anyway, right? A lot of the providers turn on V6. A lot of us have devices that can do V6 out of the box. You're not thinking about it. Your network is wide open, right? Global deployment is occurring. You see all the numbers. It's going up, 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 right? And there may be mandates, regional requirements, whatever it is. All enterprises are not all made equal. And let's try to map this to business benefits. One of them can be reduce operational costs, right? Or mitigate risk. We see a lot of enterprises looking at external facing servers. Instead of touching the inside, they're looking at just touching the external part of their network because they want to be reached. I mean, banks, a lot of the banks are looking at external facing, right? Because they want to be reached by everybody. Governments are doing the same thing. Cities are doing the same thing. You know, smart cities are all looking at doing something like this. Or you have some kind of requirement, some kind of regulatory requirement. Anyway, then once you know this, start building your roadmap. These dots are on purpose, not connecting everything. The journey is yours. How you go about doing this is the choice of the business. And then map it onto, well, that will give me more agility if I do it this way. Or I need to deliver whatever, okay? So this is so now the talk said, well, how do I go about doing SDN and IPv6? So what the ONF is so SDN is all about creating a flow based on some kind of rules that you've been told to act upon. What about if I create a flow for IP and IP? Very simple. I just introduce this, and then I've got all my traffic caught at the edge of my network and forwarded according to the flows that are set up at my SDN-enabled devices, or just forward the information on. Very simple, nothing magical about it. It just becomes another application that talks to the controller and acts upon the traffic that it sees. This is dead easy, and a lot of vendors are doing this today. So how do I start my journey? Well, the first thing I need to recognize when I start my transformation journey, any transformation journey actually, but this one is in the context of IPv6 since we are at an IPv6 conference, is that technology is not sufficient. You need to think about security. You need to think about application. You need to build a governance model. You need to think about financial, right? What we've seen around network function virtualization transformation is that we tell the telcos who have been used to buy hardware equipment for a long time, if you continue to procure your equipment the way you've done it, but you've just gone to virtualization, you're pretty much going to spend the same amount of money. Maybe you should look at innovative financial models, right? Think about leasing. Think about pay-per-use. You are now able to do things that you were not able to do before. So think outside the box. Having all these stakeholders together at the table is 80% of the transformation work. Folks within an enterprise, they don't talk to one another. It's amazing to me. They may sit in the same office, but they really do not. And if they do talk to one another, they don't understand each other's need. Get them around the table. Do things that are quite easy, which is acquire equipment at V6. And good news is most of the equipment today is V6 capable, but the devil is in the detail. Look at building a lab, right? Validate for yourself that you don't have an issue. What we've seen is that if the business needs to be at the table, if it's only the technologist, which a lot of us are in this room, it's going to be quite difficult because the business people are going to say, I don't need this today. My network continues to work. So it's working fine, thank you. Yes, you got to spend some hours to fix this, but I don't see the need. If you map it to a business need, then the story is quite different. Okay. So build an actionable roadmap. Building this roadmap is an important step in that transformation. Again, having the idea, so I am in the bank, what are my pressure points? Need to make sure my data doesn't leave my country. So I need to know where my data is all the time. I need to have traceability. I need to know what my customers are doing. I need to know what my tellers are doing, my brokers are doing. I need to be able to build a network that is fast for my brokers so that they can commit to whatever they need to do, right? So I need to go and align the requirements. Find your low-hanging fruit. It's very often external presence, right? Work with your partners, work with your ISPs, work with your peers, right? If you are in the financial sector, understand what your competitors are doing. That's not a small thing to do. Understanding what competitors are doing is quite important in a strategic transformation. Remember, enterprises are very conservative. They're here to make business for their business. They don't do technology for the sake of technology. Recognizing this and putting an IT transformation in that lens is easy. Now, they're going to read the press, they're going to see IoT, and they're going to see mobility, and they're going to see cloud, and they may come back to their IT folks and say, can you please solve this? What we're saying here, be ahead of the curve. Plan and start with pragmatic steps. Build a table that says, I'm going to start with this project and this project. Go back to what I said around SDN. Maybe voice is your biggest pain point. You're spending too much money today on voice for your employees. Fix voice. Build a network that can deal with quality of service end-to-end. Once you've done this, now, of course, you can do it the old-fashioned way by deploying WAN optimizer throughout the network, but you're going to have choke points, and it's going to be very difficult to get ahead of the curve. I'll tell you, we are 330,000 employees inside HP. Our linked network is indeed something that we pay attention to. We've deployed a lot of optimizer. We can never get ahead of the demand, right? Especially when you have all the different time zones. So we are actively deploying SDN and, of course, IPv6 to actually address this. But it has to be tied to a business, whether you're reducing OpEx or you are delivering, agility, or you're showcasing something. So this is my wrap-up slide. So for me, if I was to say it in one slide, this is why I think these three technologies are important. SDN and NFV, as well as IPv6, are there to enable an environment where I can unlock innovation. I can build community of interest. I can deliver context-aware information, right? Because I'm no longer sharing information with my neighbor, and I'm no longer being impacted because they may be doing something on the network. I can build on-demand community of interest, and I can tear it down as fast as I've built them, right? I can create an infrastructure that is intelligent, that is context-aware, that is able to act based on a given application need. So this is all about this untapped part of the world that I think these technologies are about to unleash. And with this is my conclusion. So I'm open for question. I know it's more strategic as a talk, but I thought it was an important level setting. Okay, I'm going to be around for the rest of the 2 days. So if you have questions, as I said, we are eating our own dog food, building an SDN ecosystem, NFV platform, and of course we're deploying IPv6 and our products are IPv6 enabled. So at the end of the day, you got to do what's right for your business, enable them. Thank you.